For section 5.2, we're looking at verifying trig identities, and this is a continuation of section 5.1, and we have a little bit of a list of properties, a list of steps really that we can use as we go through and verify these identities. First thing is to work with one side at a time. We're going to get two expressions on either side of the equal sign. Usually want to pick one and simplify as you can go. Look for factoring, adding fractions, squaring binomial, kind of the algebra properties that we saw also in section 1. The fundamental identities that you were listed on page 350, you should have those out as well because those will help you. If those don't work, we can always go back and looking at converting to sine and cosine. And the key thing is we just try something. Try to simplify and see if you can get in some direction. There may be multiple ways to solve the problem, and we just need to find some way to get to that solution. So if we look at our first one, we have sine squared theta plus cosine squared theta over cosine squared, secant squared, and that's equal to 1. I'm going to simplify the left-hand side of this. And I can first start with simplifying the numerator. Because our Pythagorean identity tells us that sine squared theta plus cosine squared theta is equal to 1. So I'm going to make that equal to 1. And now I'm going to change secant. And I know secant is the reciprocal of cosine. So I can move that up and it becomes cosine squared theta over cosine squared theta. Now cosine squared theta over itself is 1. So we could say that's equal to 1, and now we've shown it's equal to itself. Okay, moving down, we have 1 over 1 minus cosine x plus 1 over 1 plus cosine x, and we want to get that to be equal to 2 cosecant squared x. So let's take the two fractions we have. We're going to add them, so we need a common denominator. I'm going to multiply the left side to the top and bottom by 1 plus cosine x. And when I do that, since the numerator is 1, it just stays the same. And then the right side is going to be multiplied by 1 minus cosine x. So then I'm left with, on the bottom, 1 minus cosine x, 1 plus cosine x. Let's simplify the top first. The top becomes 2 plus cosine x minus cosine x, so that's just 2. The bottom is a difference of two squares. It becomes 1 squared minus cosine x squared, or just 1 minus cosine squared x. Now from here, we can use our Pythagorean identity, which said that sine squared plus cosine squared equals 1, to rearrange the denominator to just be 2 over sine squared x. And then the reciprocal of sine is cosecant, so we get 2 cosecant squared x equals what we had above. Now we look up at the top right. I have secant squared x minus 1. If we start with that, that is one of our Pythagorean identities, and that's equal to tangent squared x. Then we take sine squared x minus 1, bring that down, and if I rearrange that, it's like saying negative 1 minus sine squared x, which is a little more helpful because that's one of our Pythagorean identities, and that becomes negative cosine squared x. If we bring down our tangent squared x, now we can see, well, tangent is sine over cosine. So sine squared x over cosine squared x times negative cosine squared x. I have a cosine in the numerator, cosine squared in the numerator and denominator, so I'm left with negative sine squared x. Don't forget the negative, and that matches our right side. Now to the next one. Cosecant x minus sine x equals cosine x cotangent x. This time I'm going to work with the right-hand side, and really it didn't matter which side we start with, but if I look at the right-hand side, I have multiplication, and that might be a little bit easier to break apart and combine some different pieces. So let's look here at cotangent. Cotangent is cosine over sine. Then I can say that I have cosine squared x over sine x. And cosine squared x is, with the Pythagorean identity, gives me 1 minus sine squared x over sine x. I'm now going to break this into two fractions, 1 over sine x minus sine squared x over sine x. Now 1 over sine x looks like we should change to its reciprocal, which is cosecant x. And then sine squared x over sine x just is going to become sine x. And I get cosecant x minus sine x, which matches the left side. Under our next one, we have cosecant x plus cotangent x equals sine x over 1 minus cosine x. Same idea as the last one. I'm going to work with the right-hand side first, mainly because I have some division. Maybe I can simplify with that, and eventually will turn out to what we have on the left side. It doesn't mean we can't use the left side, but that addition may prove to be a little bit difficult. Now looking at the right-hand side, I have 1 minus cosine x on the denominator. I can multiply the top and the bottom by 1 plus cosine x. And this is the conjugate to the denominator. And this is going to get sine x times 1 plus cosine x over the difference of squares, which is 1 minus cosine squared x. If I simplify the numerator, I now have sine x plus sine x cosine x. And that's over 1 minus cosine squared x. And what the denominator is now going to be used for is our Pythagorean identity, which becomes sine squared x. Now I can split it into two fractions, sine x over sine squared x plus sine x cosine x over sine x squared x. The left fraction becomes 1 over sine x. The one on the right becomes cosine x over sine x. Now, so we get the reciprocal of sine x is cosecant x, and then cosine x over sine x is one of our quotient identities, and that's going to be cotangent x. And we end up with cosecant x plus cotangent x, which matches the left-hand side. Now we're going to look at tangent squared theta over 1 plus secant theta, and that's equal to 1 minus cosine theta over cosine theta. I'm going to start with trying to simplify the left-hand side. If I look at the numerator, I have tangent squared theta. I can rewrite this with a Pythagorean identity of secant squared theta minus 1 over 1 plus secant theta. Now what I can do here is take that numerator where I have secant squared theta minus 1, and that is like a difference of two squares, and that becomes secant theta minus 1, secant theta plus 1, over, let's switch it and call it secant theta plus 1. Now this simplifies to leave me with secant theta minus 1. And now I'm kind of looking at it, I may be stuck. So what I'm going to do here is bring down the right side to kind of see where I'm at. 1 minus cosine theta over cosine theta. And maybe I can start simplifying the right-hand side a little bit and kind of meet it in the middle ground. Because on the right-hand side, I can make it 1 over cosine theta minus cosine theta over cosine theta. Now, the reciprocal of cosine is secant, and then cosine over cosine is 1, so it actually ends up matching secant theta minus 1. Now it's fine to use both sides of the equation. I wouldn't try to solve them both at the same time because you may go in the wrong direction. But if you get stuck with one side, there's nothing wrong with trying to work the other one. And sometimes it's a combination of the two that'll help you have them meet. Okay, our last two here. I have tangent cubed x equals tangent x secant squared x minus tangent x. I'm going to start with just trying to simplify the left-hand side, because I can write this as tangent x times tangent squared x. And why this is important is not so much that tangent x, but tangent squared x is part of our Pythagorean identity, which is going to be secant squared x minus 1. Now I can distribute, and I get tangent x secant squared x minus tangent x, which matches the right-hand side. We're going to take the same approach on the next one with our cosine cubed and sine to the fourth x. For this one, the fact that cosine has an odd power, I can do cosine x times cosine squared x. Let's switch those two. Let's move the 2 over here. Times sine to the 4th x. Because cosine squared x is part of our Pythagorean identity, that becomes 1 minus sine squared x, cosine x, sine to the 4th x. And if we look at where we want to go, we want to get sine to the 4th and sine to the 6th, which looks like I'm going to multiply and distribute out that sine to the 4th and kind of move the cosine to the end. So now I have sine to the 4th x minus sine to the 6th x in parentheses times cosine x, and that matches the right side.